What if the black holes we imagine were just a small part of the story? This audiobook explores the idea that there could be fifth-dimensional black holes, invisible to our telescopes and so strange that they defy all intuition. If the universe has more dimensions than we perceive, these objects could be right here, hidden, leaving traces that we are just beginning to recognize. Black holes are, in essence, regions of space where gravity is so intense that nothing, not even light, can escape their pull. Imagine a gigantic funnel that swallows everything that comes too close. This extreme gravitational force originates when a massive star exhausts its fuel and collapses under its own gravity, creating an object so dense that it alters the very fabric of space and time around it. Understanding black holes is closely related to Albert Einstein's theory of relativity, one of the cornerstones of modern physics. This theory revolutionized our way of seeing the universe, challenging us to think of space and time as an interconnected entity. It's as if the universe is woven with invisible threads, and black holes are the knots that distort that fabric. Have you ever imagined what the universe would look like from the perspective of a black hole? As we approach its event horizon, the invisible boundary that marks the point of no return, time seems to slow down. This phenomenon, known as time dilation, is one of the many wonders that arise from relativity. The experience of time becomes subjective depending on our position in space. The importance of black holes goes beyond their mere existence. They are natural laboratories that allow us to explore the limits of our physical theories. What happens at the heart of a black hole, at its singularity? That is a question that has intrigued scientists for decades. The singularity is a place where the laws of physics as we know them seem to break down, and it is here that science meets the unknown. Black holes also teach us about gravity, that force that holds planets and stars together. But what happens when gravity becomes so intense? Black holes act as gravitational magnets, attracting everything around them. This attraction can lead to spectacular phenomena such as the formation of accretion disks, where matter is devoured and heated to unimaginable temperatures. And not only that, black holes are also a gateway to exploring the cosmos. The way they interact with their environment can reveal crucial information about the evolution of the universe. In other words, by studying these objects, we are not just looking into the void, but we are unraveling the very history of the cosmos. Curiosity about black holes has led to exciting explorations. How are they detected if they are invisible to light? Scientists have developed ingenious techniques such as using gravitational waves and radio telescopes to observe their effect on nearby stars. This has opened a window to a hidden universe where black holes become the protagonists of a cosmic drama. However, the mystery does not end there. As we delve deeper into the subject, we find theories suggesting the existence of black holes in additional dimensions, a concept that could transform our understanding of physics. These bold ideas lead us to question the very nature of space and time, inviting us to imagine a universe much more complex than we can see. The impact of black holes on popular culture is also significant. From movies to novels, their presence has inspired generations, making them symbols of the unknown and the unexplored. The way they are portrayed in fiction often reflects our deepest fears and fascinations about the universe and our place in it. As we progress on this journey through black holes, it is crucial to remember that, although they are fascinating objects, they also represent the limits of our knowledge. Each discovery raises new questions, and science advances by leaps and bounds to unravel these mysteries. The quest for answers about black holes leads us to reflect on the future of space research and our innate desire to understand the unknown. In conclusion, black holes are much more than mere astronomical phenomena. They are bearers of cosmic secrets that challenge us to expand our understanding of the universe. By addressing these mysteries, we find ourselves at the intersection of human curiosity and science, where each answer opens the door to new questions. And so, the pursuit of knowledge continues, illuminating the path toward understanding our place in this vast and mysterious cosmos. Black holes are one of the most fascinating phenomena in the universe, but what are they really? To understand this, we must first imagine a massive star much larger than our Sun. When a star exhausts its fuel, its core collapses under the force of its own gravity. This collapse is so powerful that a region of space is formed where gravity is so intense that nothing, not even light, can escape from it, and that's how black holes are born. Think of it this way. If Earth's gravity is like a magnet that attracts everything nearby in a black hole, that attraction intensifies to unimaginable levels. The boundary that marks the point of no return is called the event horizon. Imagine crossing an invisible line. Once you do, there's no turning back. Everything that ventures into a black hole is lost forever in the darkness of space. But what is inside a black hole? This is one of the most intriguing questions scientists are trying to answer. At the heart of a black hole lies the singularity, a point where the laws of physics as we know them cease to apply. The density is infinite and gravity is so strong that mathematics cannot describe what happens there. It's like trying to imagine a world where the rules that govern our reality make no sense. Now let's talk about how black holes form. When a massive star reaches the end of its life, it explodes in a supernova. This spectacular event can shine brighter than an entire galaxy for a brief moment. But what remains of that explosion in some cases is a core that collapses to become a black hole. Imagine a balloon that deflates rapidly. As it deflates, all its mass concentrates into an ever smaller point. That's what happens to matter in a black hole. There are different types of black holes, each with its own story. Stellar black holes, for example, are the result of the collapse of individual stars, while supermassive black holes, found at the center of most galaxies, can contain millions or even billions of times the mass of the Sun. This raises a fascinating question. How is it possible for such a large black hole to form? Scientists believe that these black holes may have grown over billions of years, devouring stars and gas around them. But black holes are not the only ones in the universe. Have you considered the idea of primordial black holes? They are believed to have formed in the early moments after the Big Bang, when the universe was an incredibly hot and dense place. These primordial black holes could be much smaller than stellar and supermassive ones, and some scientists even suggest they could be related to dark matter. The complexity of black holes doesn't stop there. Each one acts as a master of deception. As you approach a black hole, time begins to behave strangely. From our perspective, time seems to slow down near its event horizon. So if you could observe someone falling into a black hole, it would appear that they move more slowly until they disappear into the darkness. This is due to the intense gravitational force that distorts the space-time around it. The idea of black holes may seem terrifying, but it is also incredibly exciting. What if you could travel through one? Some scientists have proposed that black holes could be gateways to other universes, or even to different moments in time. This leads us to a fascinating question. Could black holes be a way to travel through time? As we explore the mystery of black holes, we must also consider their impact on the universe. These colossal objects not only absorb matter, but also affect the stars and galaxies around them. They attract gas and dust, feeding off their surroundings, and in turn can influence the formation of new stars. So, although they may seem like relentless devourers, they are also an integral part of the cycle of creation in the cosmos. The complexity of black holes also raises questions about the nature of time and space. Are they really the end of the line, or could they be portals to new dimensions? As we delve deeper into these questions, we discover that black holes are more than just simple astronomical phenomena. They are keys to unlocking the secrets of the universe. Human curiosity drives us to keep investigating. With each advance in technology and observation, we get one step closer to unraveling the mysteries surrounding these enigmatic objects. From telescopes that observe in wavelengths our eyes cannot perceive, to experiments in laboratories trying to recreate the extreme conditions of a black hole, the search for answers continues. In conclusion, black holes are much more than mere voids in space. They are places where the rules of physics are challenged, and where the deepest questions about existence are found. As we continue to explore the universe, black holes remind us that there is still much to discover and that despite their terrifying nature, they are an essential part of the story of the cosmos. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. Albert Einstein's theory of relativity is one of the cornerstones of modern physics, but what does it really mean? To understand its relevance, especially in the context of black holes, it is essential to explore how Einstein changed our perception of space and time. Relativity is not just a mathematical formula, it is a way of viewing the universe that challenges our intuition. First, let's visualize space and time as a fabric, a large surface that can be bent and stretched. When there are no massive objects, this fabric is flat. However, when we place a heavy object like a star or a planet, the fabric deforms, creating a dip. This dip is a way of representing gravity. The greater the mass, the greater the deformation. This is the essence of general relativity. Gravity is not a force acting at a distance, but the result of the curvature of space-time. So how does this relate to black holes? When a massive star exhausts its nuclear fuel, it can no longer hold itself against its own gravity. At this point, the star collapses, and the deformation of the space-time fabric becomes so extreme that it creates a black hole. From a relativistic perspective, the black hole is a region where the curvature of space-time is so intense that nothing, not even light, can escape. But what happens at the event horizon, that invisible boundary surrounding the black hole? The event horizon is like the edge of an abyss. Once we cross that limit, there is no turning back. Relativity tells us that time behaves strangely in this region. For an observer far from the black hole, time seems to slow down as an object approaches the horizon. However, for the falling object, time continues to pass normally. This disconnection between observers is one of the most fascinating features of relativity. Moreover, the theory of relativity also teaches us that time and space are not separate entities, but are intrinsically connected. This connection becomes crucial when we explore the nature of black holes. Inside, the existence of a singularity is proposed, a point where density is infinite and the laws of physics as we know them cease to apply. This raises an intriguing question: what happens at that point? It is here that relativity meets quantum mechanics, creating a conflict that scientists are still trying to resolve. Relativity tells us that gravity can curve space and time, but quantum mechanics is based on completely different rules. The search for a theory that unifies both disciplines is one of the great challenges of modern physics. A surprising aspect of relativity is that it applies not only to massive objects but also to light. When light passes near a black hole, its path curves due to the intense gravity. This means that black holes are not just voracious consumers of matter, but they can also affect the light around them. This interaction has been observed in phenomena such as gravitational lensing, where the light from distant stars is distorted as it passes near a black hole. However, what does this mean for the future of our understanding of the universe? Relativity has opened the door to a new way of viewing the cosmos, where time and space are flexible and dynamic. It invites us to question what we think we know about reality and to explore beyond the limits of our current understanding. Einstein's theory of relativity has also led to the creation of technologies that we use in our daily lives. For example, the Global Positioning System, or GPS, needs to account for relativistic effects to provide accurate locations. This is a reminder that Einstein's ideas are not just abstract theories, but have practical applications in the real world. In summary, Einstein's theory of relativity not only helps us understand black holes, but also offers us a broader view of the universe. It teaches us that what seems to be a solid reality is, in fact, a constantly changing fabric, influenced by mass, energy, and gravity. This understanding is essential for unraveling the mysteries surrounding black holes and their role in the cosmos. As we delve deeper into the study of black holes and their implications, we realize that there is still much to discover. Relativity has provided us with the tools to explore these astonishing phenomena, but each answer generates new questions. And so the journey continues, taking us to a place where curiosity and science intertwine in an endless quest to understand the universe in all its complexity. Black holes are like cosmic monsters that devour everything that comes too close to them. But what really happens when a black hole comes into play in the vast universe? To understand this, it is essential to know how they affect the space and time around us. Imagine that space-time is a large elastic sheet. When you place something heavy like a bowling ball in the center of that sheet, it sinks. Now, if you roll a marble near that ball, it will get caught in its attraction. Similarly, a black hole creates a distortion in the fabric of space-time, affecting everything around it. Gravity, which is the force that keeps our feet on the ground, behaves differently near a black hole. As we approach one, gravity becomes so intense that even light cannot escape. How is it possible that light, which travels at an astonishing speed, cannot break free from its pull? The answer lies in how black holes distort space and time, creating what is known as the event horizon. This horizon is like a point of no return. Once you cross that boundary, there is no turning back. The relationship between dimensions and gravity becomes a fascinating aspect of this story. In our daily lives, we perceive three dimensions: length, width, and height. But what if there are additional dimensions that we cannot see? Some physicists suggest that inside a black hole, the rules of these dimensions could change drastically. Imagine a world where dimensions are intertwined in ways we can barely begin to comprehend. Gravity in those spaces would be even more intense and could give rise to unimaginable phenomena. When thinking about black holes, it is common to wonder if they could exist in other dimensions. According to some theories, there could be black holes in higher dimensions that behave in completely different ways than those we know. This leads us to the idea that the universe is much more complex than we perceive. Each black hole could be a doorway connecting different realities or even different universes. The distortion of space-time not only affects things that fall into a black hole, but also has repercussions in the surrounding environment. Light passing nearby bends, meaning we could see distorted images of objects that are behind the black hole. This phenomenon is known as gravitational lensing. The extreme gravity acts like a giant lens, allowing us to glimpse parts of the universe that would otherwise be hidden. But what about the matter that falls into a black hole? As it approaches, it accelerates and heats up, emitting radiation in the process. This phenomenon allows us to detect black holes through the energy they emit before being swallowed. Thus, even though we cannot see them directly, we can observe their impact on the universe. It's as if they are invisible predators, leaving clues in the fabric of the cosmos. The effect of a black hole on space-time can be so extreme that it could influence time itself. Near a black hole, time slows down compared to an observer who is far away. This means that if we could travel to a black hole and return, we might find that years or even centuries have passed in the outside world while only a few minutes have passed for us. This phenomenon is known as time dilation and is one of the many wonders presented by relativity. The implications of these effects are profound and puzzling. The way we perceive reality could change dramatically if we could find a way to approach a black hole. It leads us to question our understanding of time and space. What would it mean for us if time is not a straight line, but a fabric that can be bent and distorted? A black hole is not just a dark and mysterious object, it is a natural laboratory where the laws of physics are tested. Each black hole offers a unique opportunity to explore fundamental questions about the universe. How does matter behave under extreme conditions? How do gravity and relativity interact in these situations? The existence of black holes also raises philosophical questions about the fate of matter and energy. What happens to the matter that falls into a black hole? Is it destroyed, transformed, or transported elsewhere? These questions still lack definitive answers, adding an air of mystery to these phenomena. The relationship between black holes and space-time also leads us to consider the possibility that they are an essential part of the structure of the universe. Some scientists suggest that they could play a crucial role in the formation of galaxies. As matter accumulates and falls into supermassive black holes, it could influence the dynamics of surrounding stars and gas, shaping the galaxies we see today. In summary, black holes are not just entities that absorb light and matter, they are enigmatic and complex, challenging our understanding of the laws of physics. As we explore their relationship with space-time, each discovery gives us a new perspective on the cosmos. Thus, every question we ask about these cosmic monsters brings us one step closer to unraveling the secrets of the universe. Black holes are fascinating phenomena, but did you know that not all of them are the same? There are different types of black holes, each with its own characteristics and mysteries. Let's delve into this intriguing universe of black hole classification, where diversity is as vast as the cosmos itself. Stellar black holes are perhaps the most well-known. They form when a massive star exhausts its nuclear fuel and collapses under its own gravity. Imagine a star that shines brightly for millions of years, but at the end of its life, it becomes a compact sphere so dense that nothing, not even light, can escape its gravitational pull. This process is like a supernova, where the star explodes and leaves behind a core that becomes a black hole. Have you ever wondered how many stellar black holes might exist in our galaxy? On the other hand, we have supermassive black holes, which are even more enigmatic. These gigantic black holes reside at the center of almost every galaxy, including our Milky Way. Their mass can be equivalent to millions or even billions of times that of the Sun. The question that arises here is, how do these colossi form? Some scientists suggest that they may have developed from the merging of smaller black holes or from the accumulation of gas and matter over billions of years. Think of it as a magnet that attracts everything around it, growing with each particle it captures along the way. What about primordial black holes? These are truly intriguing, as they are believed to have formed shortly after the Big Bang, in the extreme heat and density of the early universe. Their existence is still theoretical, but some scientists argue that they could be responsible for the dark matter that makes up a large part of the universe. Imagine these primordial black holes as remnants of the universe's earliest moments, small relics that tell us stories of the cosmos in its infancy. The classification of black holes doesn't stop here. There are theories suggesting the existence of black holes in different dimensions. What does this mean? Some physicists speculate that if the universe has more dimensions than we can perceive, there could be black holes in those additional dimensions. This opens the door to a world of possibilities where the physics of black holes transcends conventional understanding. So, could we really be surrounded by black holes that we cannot see yet play a crucial role in the structure of the universe? Curiosity about black holes also leads us to reflect on their size and mass. While stellar black holes can have a mass ranging from a few to several tens of times that of the Sun, supermassive black holes are titans in comparison. But what happens when one black hole encounters another? The merging of black holes is a spectacular cosmic event that releases enormous amounts of energy, detectable in the form of gravitational waves. Can you imagine what it would be like to witness such an event in the vast ocean of space? Each type of black hole also has its own personality in terms of how it interacts with its surroundings. Stellar black holes, for example, can feed on the matter from nearby stars, creating accretion disks that emit bright radiation. In contrast, supermassive black holes often have disks of matter swirling around them, and their gravitational power can influence the formation of new stars and galaxies. Could it be that life itself in the universe depends on the existence of these dark giants? In the quest for answers, scientists have developed advanced technologies to detect these mysterious objects. Each discovery about the different types of black holes not only helps us understand their nature, but also offers clues about the evolution of the universe as a whole. Each black hole tells a story, and the classification of these phenomena allows us to grasp a part of that narrative. As we explore these types of black holes, it becomes clear that each plays a different role in the vast fabric of the cosmos. From stellar black holes that are born and die in a cycle of creation and destruction, to supermassive ones that orchestrate the dance of entire galaxies, we are faced with a diversity that challenges our understanding. In this context, the question that lingers is, what other secrets could black holes reveal to us in the future? With each new advance in technology and research, we are closer to unraveling the mysteries surrounding these fascinating phenomena of the universe. The exploration of black holes is not just a journey into the unknown, but an adventure that invites us to rethink our perception of space, time, and matter itself. The next time you look up at the starry sky, remember that among those twinkling lights, there could be black holes of different types, each with its own story and mystery. The classification of black holes is not merely an academic issue, but a pathway to understanding our place in the universe. Human curiosity has always driven exploration. And in the case of black holes, that drive leads us to delve into the darkest enigmas of the cosmos. Is it possible that black holes exist not only in our known universe, but also in dimensions we have never been able to observe? As we delve into the intriguing world of fifth-dimensional black holes, we are faced with a series of fascinating questions. What do these additional dimensions really imply, and how could they change our understanding of space and time? The idea of additional dimensions may seem straight out of a science fiction movie. However, in modern physics, these theories are taken seriously by many scientists. In a three-dimensional universe, gravity is a force that manifests in ways we can observe through everyday phenomena. But what would happen if there were more dimensions that we cannot see directly? Could these hidden dimensions influence how black holes behave? In string theory, one of the most important proposals in modern physics, it is suggested that fundamental particles are not points but tiny strings that vibrate in multiple dimensions. Some of these dimensions are so small that we cannot detect them. Imagine you are in a classroom and there is a door leading to a hallway. If the hallway is very narrow, we might not notice that there is an additional path connecting to other rooms. Could black holes be doors to those multi-dimensional hallways? Black holes in additional dimensions could, in theory, act as portals or bridges to other universes. But how would this work? If a black hole in our universe is like a funnel that traps everything that comes close, a black hole in an additional dimension could be a funnel that connects to other funnels in different dimensions. This opens up endless possibilities about how other universes might exist and how they could interact with ours. The notion that our universe is just one of many possible realities is mind-boggling. What if we could pass through a black hole and emerge in a completely different dimension? Perhaps there the laws of physics are different, or maybe gravity behaves differently. Could we find other forms of life there, or even other versions of ourselves? The questions multiply, and each answer seems to lead us to more mysteries. A fascinating concept in this realm is that of the brain. According to some theories, our universe could be a brain, a kind of membrane floating in a higher dimensional space. In this context, black holes could be the places where the brain folds over itself. Imagine a sheet of paper that is folded. The points that were once separated on the surface of the sheet are now closer together. This could mean that passing through a black hole in our universe could take us to a different point in another dimension. However, the idea of fifth-dimensional black holes is not without controversy. Many scientists are skeptical, arguing that there is no direct evidence to support the existence of these additional dimensions. Is string theory a way to explain phenomena that we do not yet fully understand? The search for answers takes us to new frontiers in theoretical physics. Despite the doubts, imagination plays a crucial role in science. Who could have imagined that black holes could be more than just simple regions of space where gravity is so strong that nothing can escape? The possibility that they are doors to other worlds is not only astonishing, but also challenges us to think beyond what we consider reality. Fifth-dimensional black holes also invite us to reflect on the nature of time. If time is a dimension, could we experience it differently in an additional dimension? The idea that time could flow in different ways elsewhere could revolutionize our understanding of causality and destiny. The implications of these concepts are enormous. If black holes can indeed act as portals, this could radically change our search for life on other worlds. Perhaps in additional dimensions, there are civilizations that have managed to master their own black holes and, as a result, have explored their universe in ways we can only dream of. As we explore these ideas, we must not forget that science is a continuous journey. Each discovery leads to new questions, and each answer is just one more step in our quest for knowledge. The idea of fifth-dimensional black holes reminds us that the universe is a place full of mysteries, many of which are still waiting to be uncovered. Curiosity is what drives scientists to keep investigating. As we develop new technologies and methods to explore the cosmos, it is possible that one day we will be able to answer these fundamental questions about the structure of the universe and the nature of black holes. In conclusion, fifth-dimensional black holes are not just an abstract concept, but an invitation to expand our minds and explore the unknown. Science fiction is increasingly close to real science, and the idea that there is more to the universe than we can see is a reminder that there is always more to discover. So are you ready to keep exploring space and time? The doors to the unknown are waiting to be opened. What is at the heart of a black hole? Is it simply a place where gravity has gained so much power that nothing can escape, not even light? To understand this, it is important to talk about singularity and the event horizon. Two essential concepts that help us unravel the mystery of these enigmatic cosmic phenomena. The singularity is the core of a black hole, a point where density is infinitely high and the laws of physics, as we know them, cease to apply. At this point, matter is compressed into a ridiculously small space, creating a situation where everything we know about the universe seems to break down. Imagine a soccer ball being crushed down to a point the size of a marble. That is the idea of singularity, a concentration of mass and energy that defies our understanding. But what about the event horizon? This is the boundary surrounding a black hole, a point of no return. Once you cross this imaginary line, there is no turning back. The gravity is so intense that not even light can escape. To put it in perspective, think of a funnel. The edge of the funnel is like the event horizon. If something falls inside, it inevitably heads toward the deepest part where the singularity lies. So how does this event horizon form? When a massive star exhausts its nuclear fuel, it can no longer support itself. Its core collapses under its own gravity, and at that moment, if the mass is sufficient, a black hole forms. The event horizon is established based on the mass of the black hole, creating a point of no return that marks the boundary of its gravitational influence. As one approaches a black hole, strange effects are experienced. For example, time behaves oddly. As one gets closer to the event horizon, time seems to slow down. From the perspective of an external observer, someone heading toward the black hole would appear to move slower and slower until, upon crossing the horizon, they seem to stop in time. But for the one crossing, time continues its normal course. It's like being in a slow-motion movie, where everything outside moves quickly while you feel motionless. The singularity and the event horizon are crucial for understanding how black holes affect their surroundings. For example, the intense gravity of a black hole can attract matter from its surroundings, creating an accretion disk. This disk is made up of gas and dust spinning at high speeds, heating up and emitting radiation in the process. The energy produced in this disk is so powerful that it can be detected millions of light years away. But here arises another intriguing question. What happens to the information of the matter that falls into a black hole? According to the laws of physics, information is never lost. However, when something crosses the event horizon, it seems to disappear forever. This paradox has led to intense debates among physicists, and resolving this dilemma could change our understanding of reality itself. Imagine you have a book full of information. If you put it into a black hole, it seems that the information disappears. However, some scientists suggest that somehow the information might be encoded on the event horizon. It's as if the cover of the book retains a trace of what was inside, even when the content has vanished. This idea, while intriguing, is still far from being proven. Black holes also offer us a window into the nature of the universe. By studying their singularity and event horizon, scientists can learn more about gravity, time, and space. This research helps us understand not only how the cosmos works, but also how the structures we see today, such as galaxies and star clusters, formed. Moreover, black holes play a fundamental role in the evolution of the universe. It is believed that supermassive black holes, found at the center of most galaxies, influence star formation and the dynamics of galaxies. This connection between black holes and galaxies is an active area of research that promises fascinating revelations about our universe. As we advance in our understanding of singularity and event horizon, we also face deeper questions about the nature of reality. Are there hidden dimensions that could offer answers? How are black holes related to quantum mechanics? These questions lead us to explore even more abstract and exciting concepts. The physics of black holes is a constantly evolving field. Each discovery opens new lines of inquiry and raises more questions. Will we ever fully understand what happens at the heart of a black hole? With each advance, we get a little closer to unraveling the secrets that have been hidden in the universe since its creation. In summary, the singularity and event horizon of a black hole are key elements in our quest to understand the universe. They challenge us to think beyond the limits of conventional physics and explore the depths of reality. Every question that arises is an invitation to keep investigating, to keep discovering, and to keep marveling at the mysteries that surround us. In the end, black holes are not just astronomical phenomena. They are portals to knowledge and the exploration of the unknown. Black holes are true wonders of the cosmos, but what happens when you get close to one? The extreme gravity they exert can be hard to imagine, but let's try to unravel it. As you approach a black hole, the gravitational force increases spectacularly. It's like being on a roller coaster plummeting into the abyss, where gravity pulls you with a force you've never experienced before. What would happen if you got too close? There is an invisible boundary around a black hole called the event horizon. This is the point of no return. If you cross that threshold, there is no turning back. The gravity is so intense that not even light can escape, making the black hole invisible. In this sense, we could compare it to a deep, dark well. Although you can't see the bottom, you know that anything that falls in will not return. As you get closer, what you might experience is an astonishing phenomenon known as spaghettification. With such a curious name, right? Imagine a spaghetti that stretches and elongates. As you approach the black hole, the part of your body closest to it would experience a gravitational force much stronger than the part that is farther away. This would stretch you like pasta, causing any object that ventures too close to be shredded in an instant. But why is gravity so strong in these places? The answer lies in the incredible density of the matter concentrated in a black hole. When a massive star exhausts its fuel, it collapses under its own gravity and becomes a black hole. Imagine compressing the entire mass of a star the size of our sun into a space of just a few kilometers. That concentration of mass generates a gravitational field that defies everything we know. The gravitational effects of a black hole not only affect objects that approach it, but also light. Light passing near a black hole can be bent, creating what is known as gravitational lensing. It's like having a crystal that distorts the image of what is behind it. Astronomers use this effect to study distant objects in the universe, as black holes can act as enormous cosmic lenses. There's more. Extreme gravity can also cause time to behave strangely. Imagine you are watching a clock as you approach a black hole. From your perspective, time would continue to flow normally, but for an observer far from the black hole's gravity, time would seem to slow down. This phenomenon is a direct result of Einstein's relativity. So indeed, if someone were watching your journey toward the event horizon, they might think you are moving more slowly as you get closer. But what happens to the matter that falls into a black hole? Once it crosses the event horizon, it becomes part of the singularity, the point where density is infinite and the laws of physics as we know them cease to apply. It's as if everything we know about the universe fades away at that point. The singularity is a mystery we have yet to solve. extreme gravity also affects celestial bodies orbiting around a black hole. Stars and other objects can be drawn toward it, and their movement can be extremely complicated to predict. This creates a cosmic ballet where gravitational forces play a crucial role, making astronomers feel like conductors trying to understand these movements. One might wonder, are there soft black holes? The answer is no. The gravity found near a black hole is always intense and ruthless. However, from a distance, a black hole may appear peaceful. It is in close proximity that its true nature is revealed. It serves as a reminder that the universe is full of surprises, some of which are terrifying. Human curiosity is insatiable. We wonder how these phenomena affect not only our understanding of the universe, but also the possibility of life on other worlds. If extreme gravity can create such complex situations, what other wonders and mysteries might be hidden in the dark corners of the cosmos? Finally, it is important to remember that although black holes may seem terrifying, they are also an integral part of the universe. They help us understand phenomena such as galaxy formation and the evolution of the cosmos. Discovering more about them allows us not only to learn more about the universe, but also about ourselves and our place in it. So, as we reflect on the nature of black holes and their extreme gravitational effects, let us remember that every question that arises opens the door to new explorations and discoveries. Science advances by leaps and bounds, and each answer becomes a stepping stone toward a deeper understanding of the universe we inhabit. Wormholes are one of the most fascinating and mysterious ideas in the field of theoretical physics. But what exactly are they, and why are we so interested in them? Imagine a sheet of paper. If you fold the paper in such a way that 2 points on its surface touch, you have created a shortcut between them. This is a simplified way to understand what a wormhole could be, a tunnel that connects different regions of space-time, allowing travel from one place to another without having to cover the distance between them. The idea of wormholes arises from Einstein's general relativity equations. In theory, if black holes are regions where gravity is so intense that nothing can escape, then wormholes could be those tunnels that, if they exist, would allow passage through them. But could we really traverse them? Would they be safe? And most intriguingly, could they allow us to travel through time? Over the years, many scientists have explored the possibility that these tunnels are real. Some suggest they could be used as portals to travel to distant galaxies or even to different moments in time. This raises the question, if we could travel through time, what would we change? Would we be able to correct past mistakes or, on the contrary, create paradoxes that would alter the course of history? However, it's not all that simple. Most theories about wormholes also suggest that for them to work, we would need a form of exotic matter, which would have very unusual properties, such as negative energy. This matter has not been found in nature, leading us to question whether wormholes are more than just simple theoretical ideas. Are they an illusion? Or is there something deeper behind this fascinating notion? Wormholes also spark interest in how they could affect our understanding of the universe. If they existed, they could offer answers to some of the most complex questions about the nature of space and time. Imagine being able to traverse a wormhole and emerge in a distant galaxy. That would not only change our way of viewing the universe, but also open the door to the possibility of finding life on other worlds. The idea of wormholes has been popularized in culture, from movies to science fiction books, but how many of these representations are truly plausible? Some works of fiction have adopted the concept of wormholes as a way to explore deeper themes, such as human connection across time and space. But could it be that fiction is showing us a future we do not yet fully understand? As science advances, scientists continue to investigate the possibilities of wormholes. With the use of advanced technology such as telescopes and computer simulations, they are trying to unravel the secrets that may be hidden in these theoretical structures. This leads us to a crucial question. What discoveries are yet to come in the future? Could we be closer to understanding or even finding evidence of these mysterious tunnels? Modern physics faces a significant challenge, reconciling general relativity with quantum mechanics. Wormholes could be the key to uniting these seemingly opposing theories. If we manage to understand how they work, we could open a new chapter in our understanding of the cosmos. What implications would this have for our place in the universe? When contemplating the idea of wormholes, it is important to remember that, although they are still theoretical, they represent the frontier of human knowledge. Each new discovery in physics brings us one step closer to understanding the nature of the universe and our place in it. What else does the future hold in this quest to unravel the secrets of the cosmos? Imagine a future where humans can explore other worlds through these cosmic tunnels. The possibility of instantaneously traveling to distant places would not only transform our understanding of space exploration, but could also change the way we view our own lives on Earth. How would these new realities affect us? As science progresses, it is essential to keep an open mind. Although today wormholes are just a theory, the history of science is full of ideas that seemed impossible before being proven. Perhaps in the not-so-distant future we will discover that these structures are more than just a simple concept and could be a fundamental part of the universe's structure. In summary, wormholes are a captivating topic that invites us to explore the depths of modern physics. The questions arising from their existence continue to challenge us to think beyond the known. Will these tunnels be a reality in the future? Only time and research will tell, but what is certain is that they will remain a subject of fascination and inspiration for generations to come. The information paradox of black holes is one of the most fascinating and perplexing dilemmas in modern physics. What happens to the information that falls into a black hole? Is it lost forever, or is there a way to recover it? The answer to this question not only helps us understand black holes better, but also challenges our most basic notions about information itself. Imagine a book that contains all your deepest secrets. If someone takes it and burns it, is the information of those secrets lost forever? For many scientists, the idea that information can be destroyed is completely unacceptable. In the world of physics, information must be conserved, but what happens at the event horizon of a black hole seems to test this rule. When an object crosses the event horizon, it is said to have fallen into the black hole. From the outside, it appears that the object disappears from view, but where does it really go? Stephen Hawking, one of the most influential physicists of the 20th century, proposed that black holes are not as black as they seem. According to his theory, these cosmic giants can emit a form of radiation known as Hawking radiation. This suggests that somehow information might not completely disappear, but how can a black hole emit radiation if, by definition, nothing can escape its gravity? The key lies in quantum mechanics, the branch of physics that studies the behavior of particles at microscopic levels. In the vacuum of space, particles and antiparticles can appear and disappear in pairs. When this happens near the event horizon of a black hole, one of the particles might fall in while the other escapes into space. This leads to the intriguing conclusion that, although an object has fallen into the black hole, the information it represents might emerge in an unexpected way. Now let's return to the idea of information. Is it possible that the information lost in a black hole could be recovered in some form? This dilemma is known as the information paradox. Many physicists have tried to resolve it, but so far there is no consensus. Some suggest that the information is encoded in Hawking radiation. Others think it might be stored on the surface of the black hole, in a kind of memory that could be read in the future. A useful analogy is to think of a computer hard drive. If you delete a file, it might seem like it is lost forever. However, in many cases, the information can still be recovered until it is overwritten. Similarly, it could be that the information falling into a black hole is not destroyed but remains hidden in some way, waiting to be discovered. The information paradox has raised many profound questions about the nature of the universe. What does it really mean to lose information? Is it a concept that only makes sense in our everyday world, or does it have broader implications within the framework of quantum physics? These questions are not just academic. They have a direct impact on how we understand reality itself. Moreover, this paradox has also inspired new theories in physics. Some proposals suggest that black holes could be connected to other universes through wormholes, which could allow lost information in a black hole to be recovered elsewhere. This opens up a world of possibilities regarding the interconnectedness of the universe and how space and time might be intertwined in ways we do not yet fully understand. At its core, the information paradox challenges us to rethink what we know about the universe. It forces us to consider whether we truly understand how gravity, quantum mechanics, and the nature of information work. The quest for answers to these questions could lead to incredible discoveries that change our perspective on reality. So, as scientists continue to explore these ideas, the information paradox of black holes remains a topic of intense debate. As we develop new theories and technologies, it is possible that one day we will unravel this cosmic enigma. Could we discover that information is more indestructible than we think, or that the universe has a surprising way of preserving what we believe is lost? Only time will tell. The exploration of black holes and the information paradox is a reminder that, in the vast and uncertain universe, many mysteries are still waiting to be solved. Each new discovery brings us a little closer to the truth, challenging our beliefs and expanding our understanding of the cosmos. This is how science advances, not just by accumulating information, but by questioning what we already know and exploring the unknown. Black holes are more than just simple dark points in the universe. They are phenomena that have captured the imagination of scientists and philosophers alike. How is it that these mysterious cosmic objects can have such a profound impact on the evolution of the universe? To address this question, it is essential to understand the relationship between black holes and cosmology. First, let's consider the very nature of the universe. This vast cosmos, where millions of galaxies move and collide, is filled with forces that shape its structure, and at the heart of many of these galaxies we find supermassive black holes. These giants can be millions or even billions of times more massive than our Sun. But what role do they play in the formation and evolution of galaxies? The answer lies in their powerful gravity. Imagine a black hole as an extremely strong magnet in space. Its gravitational pull not only affects the stars and gas nearby, but also influences how galaxies cluster together. As material approaches a black hole, it undergoes a process of acceleration and heating, creating bright accretion disks that radiate energy in the form of light and X-rays. This phenomenon not only illuminates space, but also stimulates the formation of new stars around it. Moreover, supermassive black holes can play a crucial role in the growth of galaxies. Through a process called feedback, the energy released by material falling into a black hole can heat the surrounding gas and prevent it from condensing into new stars. Thus, these cosmic monsters have a regulatory effect on star creation, acting as cosmic guardians of galactic evolution. But black holes do not only affect their immediate surroundings, their influence can extend to much larger scales. Gravitational interactions between black holes and other galaxies can lead to galactic mergers, where two or more galaxies combine into one. This process not only transforms the structure of galaxies, but can also trigger episodes of intense star formation, giving rise to new generations of stars. A fascinating aspect of this relationship is how black holes can contribute to the expansion of the universe. Dark energy, that mysterious force that seems to be driving the acceleration of the cosmos's expansion, could somehow be related to the activity of black holes. Could it be that these cosmic entities are connected in ways we do not yet understand? The observation of black holes also provides clues about the history of the universe. By studying black holes at different stages of cosmic evolution, astronomers can trace how galaxies have changed over time. By observing these phenomena, we can gain insights into when the first stars and galaxies formed, thereby illuminating the history of our universe. The study of black holes also leads us to reflect on the ultimate fate of the cosmos. What will happen when the universe expands and cools? Some scientists suggest that black holes could be the last remnants of matter in a declining universe. As the universe cools, these black holes might become the only beacons of light in a mostly dark cosmos. In this quest to understand the role of black holes in cosmology, computer simulations have been invaluable tools. Through them, scientists can model how galaxies interact and evolve in the presence of black holes. These simulations allow us to explore scenarios that would be impossible to observe directly. The relationship between black holes and cosmology also raises profound questions about the nature of time and space. If black holes can distort the time and space around them, does this mean they can influence how we perceive time in the universe? This is a field of study that continues to challenge our notions of reality. As we continue to investigate these mysteries, we must also consider how understanding black holes can influence other areas of physics. The search for answers about their nature and impact on the cosmos could provide us with new perspectives on gravity, time, and the structure of the universe itself. The implications of black holes in cosmology are vast and complex. They take us on a journey through time and space, challenging our conceptions and stimulating our curiosity. As we continue to explore these enigmatic phenomena, each discovery brings us one step closer to unraveling the secrets of the universe. Research in this field not only provides us with answers, but also raises new questions, keeping the flame of human curiosity alive. In summary, the connection between black holes and cosmology is a thread that weaves stories of formation, evolution, and the future of the universe. Each black hole we observe is a window into the past and the fate of all that we know. The exploration of these mysteries remains one of the most exciting frontiers of science, and it is an invitation for all of us to keep questioning and learning about the cosmos we inhabit. The detection of black holes is one of the great challenges of modern astronomy. Although these mysterious cosmic objects do not emit light and are practically invisible, scientists have developed ingenious techniques to study them. How do we see something that cannot be seen? The answer lies in how black holes interact with their environment. When a black hole is in a region of space where there is matter, such as a star or interstellar gas, its extremely powerful gravity affects everything around it. This heat produces radiation that we can detect. Through special telescopes, astronomers can observe this radiation in the form of X-rays. Thus, although the black hole itself is invisible, its behavior reveals its presence. A fascinating method that has revolutionized the detection of black holes is the use of gravitational waves. What are gravitational waves? They are like the waves that form in water when you throw a stone, but instead of water, we are talking about space-time. When two black holes merge, they create waves in the fabric of space-time that travel at the speed of light. These waves were first detected in 2015 by the LIGO experiment, opening a new window for observing the universe. Thanks to this technique, we not only discovered that black holes exist, but we also began to understand how they interact with each other. Another crucial tool in the detection of black holes is the use of radio telescopes. These telescopes do not see visible light, but capture radio waves that black holes emit while consuming matter. Imagine you are at a concert, and although you cannot see the band, you can hear their music. Radio telescopes allow us to listen to the cosmic music of black holes. This technique has enabled scientists to create images of the shadow of a black hole, such as the supermassive black hole at the center of our galaxy, the Milky Way. Additionally, scientists also use observations of stars near black holes. When a star orbits a black hole, its movement reveals the presence of the black hole. This is somewhat like when you look at the waves in a pool. If you see a big wave, you can assume that something is causing that disturbance. By observing how stars move in their orbits, astronomers can infer the existence and mass of a black hole that is attracting them. Light is not only affected by black holes, but its study also helps us better understand the nature of the universe. By observing how light curves and distorts around a black hole, scientists can study the intensity of the gravitational field and how light behaves in extreme situations. This distortion can be compared to the effect a magnifying glass has on light. When looking through it, images are distorted and enlarged. Sometimes black holes are not alone. There are binary systems where a black hole and a companion star interact. These systems are particularly interesting because the matter from the star can be drawn toward the black hole, creating an accretion disk. This disk, filled with hot and bright matter, emits radiation that we can detect. The combination of the star and the black hole gives us valuable clues about how these objects form and evolve in the universe. But what about primordial black holes? They are believed to have formed shortly after the Big Bang and could be smaller than stellar black holes. We have not yet found direct evidence of them, but their existence could explain some of the mysteries of the universe, such as dark matter. Thus, the search for these black holes is crucial to unraveling the early history of the cosmos. The detection of black holes is not just a matter of scientific curiosity, it also has profound implications. Each new discovery helps us answer questions about the nature of gravity, time, and space. Every black hole we identify is like a piece of the cosmic puzzle that helps us understand the universe we live in. With advances in technology, the tools we use to detect black holes continue to improve. Projects like the Event Horizon Telescope, which captured the shadow of a black hole in 2019, are just the beginning. As we develop new technologies and methods, we are likely to discover much more about these enigmatic objects. The detection of black holes is an exciting journey that combines scientific ingenuity and human curiosity. Each new finding brings us a little closer to unraveling the secrets of the universe. In the end, the search for these objects is not only a journey into the unknown, but also an exploration of our own existence in the vast cosmos. So the next time you look at the starry sky, remember that somewhere far away, black holes are silently working, attracting matter, distorting light, and revealing the secrets of the universe, while we, from Earth, try to listen to their echoes in the fabric of space-time. The adventure is just beginning. Hawking radiation has captured the imagination of scientists and enthusiasts alike. What exactly is it, and why is it so revolutionary? In a world where black holes are considered insatiable eaters of matter, Stephen Hawking proposed a game-changing idea. Black holes are not so black after all. In fact, they can emit radiation and thus lose mass. But how is it possible that something that attracts everything nearby can also release energy? To understand this, we must delve into the fascinating world of quantum mechanics. In the vacuum of space, energy is not constant, it is in constant fluctuation. In this environment, pairs of particles and antiparticles can arise. Generally, these pairs annihilate each other in the blink of an eye, but sometimes one of the particles may fall into the black hole while the other escapes into space. What does this mean? The escaping particle becomes what we know as Hawking radiation. This radiation, although extremely weak, implies that black holes can, over time, evaporate. Imagine a balloon slowly losing air. As the balloon deflates, it shrinks and changes shape. This is how black holes might behave as they emit this radiation. But what happens to the matter that remains trapped inside? Is it lost forever? This is where the information paradox becomes intriguing. According to quantum mechanics, information cannot be destroyed. So if a black hole evaporates, where does all the information of the matter it has devoured go? This question has led to passionate debates among physicists and has opened new avenues in research. Hawking radiation also offers us a unique window into the behavior of gravity and quantum mechanics. Could this radiation be the key to uniting the two branches of physics that seem so disparate? Gravity, which governs the behavior of celestial bodies, and quantum mechanics, which describes the world at the subatomic level, often seem to be at odds. Hawking radiation may be a bridge between these worlds, challenging our preconceived notions of how the universe and time work. While Hawking radiation is a theoretical concept, its impact is already felt in the way we think about the cosmos. Can you imagine a day when we might detect this radiation? Scientists are working on methods to observe black holes and potentially capture this faint light escaping from them. It would be a milestone in our quest to understand the mysteries of the universe. But what would this mean for our understanding of physics? Moreover, Hawking's theory also invites us to reflect on the ultimate fate of black holes. In a universe where everything is in constant change, even the most voracious eaters of matter may not be eternal. The idea that black holes can evaporate and disappear is both terrifying and fascinating. What does this mean for the future of the universe? Each black hole could be a star that, instead of shining forever, has a life cycle that culminates in its disappearance. Hawking radiation also raises questions about time and causality. If a black hole loses mass over time, how does this affect our understanding of time itself? It seems that time can act in ways we do not yet fully understand, and Hawking radiation is just one of many clues that may guide us toward deeper answers. The science of black holes is constantly evolving, and each new discovery opens the door to more questions. Hawking radiation is just one example of how a simple concept can trigger an avalanche of research and theories. This reminds us that the pursuit of knowledge is an endless journey, full of surprises and enigmas. As we continue to explore these mysteries, it is essential to keep an open mind. Theoretical physics may seem like a maze of complex ideas, but each concept, each theory, is a step toward a deeper understanding of the universe. Hawking radiation is an exciting piece of this puzzle and a reminder that sometimes the most surprising answers come from the most unexpected places. Finally, the story of Hawking radiation inspires us to keep probing. It shows us that even in the vacuum of space, where it seems that nothing can escape, there are opportunities for discovery and understanding. Every small flash of light that escapes from a black hole is a reminder that human curiosity can illuminate even the darkest corners of the cosmos. So let us continue to ask, explore, and marvel at the secrets that the universe still has to reveal. Black holes have captured the imagination of scientists and enthusiasts alike, but their presence in popular culture has left an even deeper mark. From science fiction to film, their mystique intrigues us and challenges our understanding of the universe. But do we really understand what they are, or are they just a narrative device for telling exciting stories? In the vast universe of fiction, black holes are often depicted as portals or gateways to other worlds. However, the idea that a black hole could be a shortcut to another place in space or even time is more complex than it seems. In reality, these phenomena are more like gravitational traps that devour everything that comes too close. What would happen if we could cross one? Movies often paint a scenario where heroes embark on adventures through these cosmic mysteries, but science tells us that they are unlikely to emerge unscathed. Filmmakers and writers have used black holes as powerful metaphors for extreme situations in life. Think of the famous movie Interstellar, where the mission to save humanity leads characters to confront a black hole. The way the plot intertwines with relativity and time is fascinating, but it also raises an intriguing question. Could we really experience time so differently in the proximity of a black hole? Scientific answers suggest yes, but the human experience remains pure speculation. In literature, black holes have served as symbols of the unknown, a place where the rules of logic and physics as we know them seem to fade away. Authors like Arthur C. Clarke and Isaac Asimov have explored these themes, taking readers to worlds where science and imagination intersect. But to what extent are these representations based on scientific reality, while grounded in real concepts? Fiction often takes creative liberties that make us question what we truly know. Music has also found inspiration in these mysterious cosmic objects, from songs mentioning black holes to entire albums revolving around the theme of space. The influence of these phenomena in popular culture is undeniable. What do these works tell us about our own curiosity and fear of the unknown? Perhaps they reflect the human desire to explore, to understand what lies beyond our world. The impact of black holes on culture is so vast that they have even become subjects of memes and references on social media. The digital community laughs and marvels at the idea that if a black hole is powerful enough, it could swallow our planet. This blend of humor and science reminds us that knowledge about these phenomena is not just for scientists, but belongs to everyone. In a world where information is abundant, interest in the unknown continues to grow. In video games, black holes have been used as gameplay elements where players must navigate their gravitational effects. These games often combine science with playability, creating experiences that are both educational and entertaining. The question that arises is, can these games inspire the next generation of scientists and engineers? The answer seems to be a resounding yes, as interest in science often begins in childhood. However, despite their popularity, the representation of black holes in popular culture often falls short in terms of scientific accuracy. The idea that a black hole could be a journey to another dimension is tempting, but the reality is that we are dealing with forces that challenge our understanding. Is it possible that these representations distort our perception of science? Perhaps, but they may also open the door to new questions and curiosities. Documentaries have also added great value to the topic, featuring experts who explain the concepts of black holes in an accessible manner. Through graphics, interviews, and passionate narratives, these programs help demystify a subject that often seems inaccessible. How can we turn this fascination into a drive to learn more about the universe? The answer lies in the curiosity sparked by these productions. As science advances and our understandings expand, it is likely that popular culture will continue to evolve alongside it. New theories about black holes and the mysteries of the cosmos will translate into exciting and captivating stories. Each scientific discovery can inspire a new book, movie, or song that in turn brings more people closer to science. How much more can we learn from these enigmatic objects? Finally, the relationship between black holes and popular culture invites us to reflect on our own existence. By looking up at the sky and questioning what lies beyond our planet, we are also exploring our place in the universe. Could it be that in the end, black holes are not just a scientific fascination, but also a representation of our internal struggles and our desire to understand the unknown? The answer is as vast as the cosmos itself. As we continue our exploration of these cosmic phenomena, we must not forget that, while black holes are incredibly complex, they are also an inexhaustible source of inspiration. At the end of the day, their presence in our culture reminds us that despite what we still do not understand, the desire to know more is one of the most powerful forces driving us as humanity. Black holes are a fascinating phenomenon that challenges our understanding of the nature of the universe. But what happens when these mysterious celestial objects enter the realm of quantum mechanics? How could they change our view of the subatomic world? The interaction between black holes and quantum theory is a topic of intense debate among physicists, and the questions that arise are truly intriguing. The information paradox is one of the great enigmas surrounding black holes. Can information really disappear into a black hole? According to quantum theory, information cannot be destroyed. However, when it falls into a black hole, it seems to be lost forever. This dilemma poses a significant challenge, defying the laws we know and leading scientists to explore new dimensions of physics. Let's think of a black hole as if it were a giant paper shredder. When we put documents into the shredder, their content is destroyed. But what happens to the information it contained? If the information is lost, is destruction really possible in the quantum world? This type of question has led to theories that attempt to reconcile quantum mechanics with the extreme gravity of black holes. One of these theories is holography, which suggests that all the information that falls into a black hole does not disappear, but is encoded on its surface. This is like a movie projected onto a screen. Although the movie itself is no longer on the screen, the image it projects remains visible. If this idea is confirmed, it could revolutionize our understanding of reality and the universe. The idea that black holes could be portals to other universes has also captured the imagination of many. Could black holes be gateways to unknown dimensions? Some scientists suggest that wormholes might exist, functioning as shortcuts through space-time, connecting different points in the universe. But would it be possible to traverse one of these holes without being torn apart by unimaginable gravitational forces? Additionally, Hawking radiation raises another fascinating question. Stephen Hawking proposed that black holes emit a form of radiation which means that in the end they could evaporate and release the information they contain. If this is true, does it mean that lost information can somehow be recovered? This concept could be the key to understanding how gravity and quantum mechanics intertwine. Meanwhile, the search for a unified theory that combines gravity and quantum mechanics remains one of the greatest challenges of modern physics. Could we one day find a formula that explains how black holes interact with subatomic particles? The scientific community continues to work diligently to unravel these mysteries, and each advance brings us a little closer to the answer. Black holes also make us question the very nature of reality. If information can be stored and retrieved in ways we do not yet understand, what does that mean for our perception of existence? These philosophical questions are as important as the scientific ones, inviting us to reflect on our place in the cosmos. Moreover, the impact of quantum mechanics on our understanding of black holes could have practical implications. Quantum computing, for example, promises to revolutionize the way we process information. Could there be a link between how black holes handle information and how quantum computers operate? This is an exciting field that is still developing. Advances in technology are also allowing scientists to explore these questions in ways that were previously unimaginable. With increasingly powerful telescopes and satellites, we are beginning to observe the universe in ways that may help us solve the mysteries of black holes. Gravitational waves, for instance, have opened a new window into understanding these cosmic giants. On the path to discovery, however, we always find more questions than answers. The information paradox is just one example of how black holes continue to challenge our understanding. Each new theory brings with it a set of questions, and those who venture into this field must be prepared for uncertainty. As scientists continue their quest, the fascination with black holes only grows. The way these mysterious objects interact with quantum mechanics not only redefines our understanding of the universe, but also invites us to imagine what is yet to come. Exploring these concepts is not just about understanding the cosmos, but also about understanding ourselves on a deeper level. The complexity of the relationship between black holes and quantum mechanics is a reminder that we are in a constant search for knowledge. As we delve into these mysteries, we may find answers that not only expand our understanding of physics, but also connect us to the very essence of what it means to be human in a vast and unknown universe. The adventure is just beginning, and each discovery brings us one step closer to unveiling the secrets that the cosmos holds. Have you ever thought about how scientists can study something they cannot see directly? Black holes, those mysterious objects in the universe that devour everything around them, have been a source of fascination for decades. But how do we know they exist if we cannot observe them in a conventional way? This is where computer simulations come into play. These tools allow us to create visual and mathematical representations of phenomena that are beyond our physical reach. Black hole simulations are like a window into another world, a world where gravity is so intense that even light cannot escape. To understand how they work, imagine you are in a movie theater watching a science fiction film where black holes are the protagonists. The screen shows how matter behaves as it approaches one of these cosmic giants. But what is the science behind these visualizations? Researchers use complex mathematical equations derived from Einstein's theory of relativity to model the environment of a black hole. These equations describe how gravity affects space and time by introducing different variables such as the mass of the black hole or the speed of the surrounding matter. Scientists can create simulations that show how matter behaves in its proximity. This raises an intriguing question. What would happen if an asteroid got too close to a black hole? Simulations show us that matter is not only attracted but can also be torn apart. This action is called spaghettification, and it is a fascinating phenomenon. Imagine you are a spaghetti noodle stretching as you approach a black hole. In the process, the matter heats up and emits radiation, allowing scientists to detect black holes through the light emitted by the materials being devoured. But how is this translated into computer images? Each simulation begins with a series of equations that describe the behavior of matter under different conditions. Physicists create a three-dimensional model where each point represents a small part of space-time. By inputting the mass and other properties of the black hole, scientists can observe how matter disks form around it. This disk heats up to extreme temperatures and emits radiation, which translates into images we can see on our screens. Thus, science and technology come together to reveal the invisible. One of the most exciting aspects of these simulations is that they not only show us what happens near the black hole, but they also explore space-time as a whole. Effects like time dilation can be observed where time behaves differently in the proximity of extreme gravity. This raises another fascinating question. How would the universe look if we could travel close to a black hole? The answers lie in the simulations, which allow scientists to explore these ideas visually. For example, as one approaches a black hole, time slows down compared to someone who is far away. This distortion may seem straight out of a science fiction movie, but it is a scientific reality. Simulations help us understand how gravity curves space-time and how this affects our perception of reality. But not everything is wonderful. Simulations also raise difficult questions and unresolved mysteries. As scientists delve deeper into the study of black holes, new uncertainties arise. For instance, what happens inside a black hole? The singularity, the point where density becomes infinite, is a place where our laws of physics as we know them cease to function. Simulations attempt to explore this uncharted territory, but always with the same dilemma. Will we ever truly understand what happens there? Moreover, advances in technology have made simulations increasingly realistic. With the help of supercomputers, scientists can model multiple scenarios simultaneously, allowing them to observe how different variables can influence the behavior of a black hole. This ability to simulate multiple conditions opens the door to new hypotheses and discoveries. But what is the limit of what we can simulate? The answer is complex. As scientists improve their models and techniques, they also face challenges. Creating accurate simulations requires not only computational power, but also a deep understanding of the physics governing these phenomena. Although simulations are powerful tools, they are also representations of our current understanding, which continues to evolve. This raises an exciting question. What new discoveries may arise from these simulations? Black hole simulations are not only a fascinating field of study, but may also have applications beyond astrophysics. Understanding how gravity and space-time interact can provide clues about other phenomena in the universe. From the dynamics of galaxies to the formation of cosmic structures, simulations can help us unravel the secrets of the cosmos. Finally, it is important to remember that simulations are just a step on the path to understanding black holes. Each discovery and every question posed brings us a little closer to the truth about these mysterious objects. As we advance in science, simulations will continue to be a key tool in our quest to understand the universe. Who knows what mysteries the next simulations will reveal? Human curiosity and technology will continue to challenge the limits of our knowledge, and that is what makes this journey so exciting. The search for life on other worlds is one of the great mysteries that has fascinated humanity since time immemorial. In the vast cosmos, black holes appear as dark and mysterious giants, but could they play a role in the search for life beyond our planet? The answer to this question may be more complex than it seems. We often think of black holes as destructive entities, devourers of stars and matter. However, their influence on the structure of the universe is fundamental. Around these giants, disks of matter form that can be habitats for planets and other celestial bodies. These disks, although dangerous, can also be the place where conditions are suitable for the emergence of life. But how can a black hole be an ally in the search for life? The key lies in the way they influence their surroundings. Supermassive black holes found at the center of galaxies generate enormous gravitational fields that can affect star formation. Stars, in turn, are the factories of the elements necessary for life as we know it. A black hole can act as a catalyst, accelerating the formation of new stars and consequently planetary systems. Imagine a young solar system located in the vicinity of a black hole. The intense gravity of the latter could help gather matter, causing more stars to form in a shorter time. This creates a kind of stellar nursery where planets can form around those new stars. What if some of those planets have the right conditions to host life? Another intriguing aspect is the phenomenon of Hawking radiation. This theory suggests that black holes can emit small amounts of energy and particles, which could have implications for creating conditions conducive to life. Although this process is extremely slow, it serves as a reminder that even the darkest and most dangerous objects can have a positive side in the evolution of the universe. The history of our own solar system is a fascinating example. The planets closest to the Sun, such as Mercury and Venus, do not seem to have favorable conditions for life. In contrast, Earth, which is located in the habitable zone, has the perfect combination of water, atmosphere, and temperature. If a black hole influenced the formation of similar systems, it could increase the likelihood of planets like ours emerging in other corners of the universe. And it's not just about planet formation. The gravitational interactions produced by black holes can generate spectacular cosmic events, such as gamma-ray bursts. These events, although devastating, can also be catalysts for the formation of new elements and chemical compounds. In the chaos of the universe, destruction and creation often go hand in hand. Theories of life in extreme worlds are also being explored. In some places in the universe, such as the icy moons of Jupiter and Saturn, signs of underground oceans that could harbor life have been found. Could these celestial bodies be influenced by black holes in the sense that, by affecting their orbits or gravitational conditions, they facilitate the existence of these habitats? In the search for life on other worlds, astronomers are increasingly interested in exoplanets, those that orbit stars outside our solar system. Some studies suggest that proximity to black holes may be a factor determining the habitability of these planets. The combination of radiation from the parent star and the gravitational effects of the black hole could create a unique environment that favors life. However, not everything is that simple. Proximity to a black hole also poses risks. Intense radiation and strong gravity could result in hostile conditions for any form of life, but nature is cunning and has found ways to survive in the most extreme environments. Could there be organisms that have evolved to adapt to these conditions? The answer is still uncertain, but the imagination of scientists is active. The search for signals of life on other worlds is also complicated by the enormous distance involved. The light from stars and planets can take thousands or millions of years to reach us. However, black holes, by influencing the formation of stars and planetary systems, could be a beacon in the darkness, indicating where life might exist in the vast sea of the universe. As technology advances, new methods are being developed to detect exoplanets and study their characteristics. Space telescopes such as the James Webb Telescope are designed to directly observe the atmospheric composition of these distant worlds. Through these observations, scientists can search for signs of life, such as the presence of water, oxygen, or methane. At the end of the day, the search for life on other worlds is a journey of discovery. Black holes, far from being just cosmic monsters, may play a crucial role in this journey. They invite us to rethink our understanding of the universe, showing that even in the darkest and most dangerous places, there may be a glimmer of hope and the possibility that life can flourish in ways we cannot yet imagine. The search for life is not just a scientific goal, it is a quest that touches the essence of our humanity. Each new discovery brings us closer to understanding our place in the cosmos and reminds us that in the vast universe, the possibilities are as infinite as the stars that inhabit it. The next time you look up at the sky and think of black holes, remember that they may be more than just a mystery. They could be the key to discovering whether we are truly alone in the universe. Black holes are undoubtedly one of the most fascinating and perplexing phenomena in the universe. But what mysteries do we still have to unveil about them? Despite advances in our understanding, many questions remain in the air, like lost stars in a vast cosmos. For example, what really happens at the heart of a black hole? The singularity, that point where gravity is so intense that nothing can escape, raises questions that challenge our understanding of physics. Some theories suggest that the laws of physics as we know them could fade away at the singularity. But how is it possible that something as fundamental as the laws governing our universe does not apply in one place? This is one of the great mysteries that still torments us. The idea that there is a place in the universe where time and space behave completely differently is truly intriguing. Moving on to another enigma, there is the information paradox. When an object falls into a black hole, what happens to the information it contains? Quantum theory tells us that information cannot disappear, but black holes seem to contradict this idea. Is the information really lost forever, or is there some way it could be recovered? These questions have led to intense debates among physicists, challenging our fundamental notions of reality. Additionally, let's talk about dark matter and dark energy. Although they are not directly related to black holes, their existence raises more questions than answers. Could there be a link between these mysterious forms of matter and black holes? Some scientists suggest that black holes could be the key to understanding the nature of dark energy. However, the truth is that we are still in the dark regarding these topics. The concept of wormholes also adds another layer of mystery. These theoretical structures could, in theory, connect different points in space-time, but are they really possible? If they existed, could they allow us to travel through time or between galaxies? While many believe they are just speculation, the idea that we could cross the universe in the blink of an eye remains an alluring dream. Then there is the issue of how black holes affect the evolution of the universe. Supermassive black holes at the centers of galaxies seem to play a crucial role in the formation and growth of these structures. Could they be influencing how galaxies cluster and evolve? This is an active field of study, and each discovery brings us a little closer to understanding how these giants fit into the cosmic puzzle. Another intriguing mystery is the possibility that black holes exist in additional dimensions. Some theories suggest that we might live in a universe of multiple dimensions and black holes could be portals to these other worlds. But how could we know if this is true? The idea of additional dimensions is both perplexing and exciting, raising questions about the very nature of reality. As technology advances, the detection of black holes becomes increasingly sophisticated. However, there is still much we do not know about them. How can we be sure that what we are observing is truly a black hole? Science is advancing by leaps and bounds, but mysteries multiply at the same pace. Black holes could also have implications for the search for life on other worlds. How does their presence influence the habitability of galaxies? The extreme gravity of a black hole could alter the course of planet formation and the evolution of life. As we seek answers, each discovery leads us to new questions. Finally, it is important to recognize that the study of black holes is intertwined with many other fields of science. Quantum physics, cosmology, and astrophysics come together in an effort to unravel these mysteries. Each new theory, each new discovery raises even more questions. Black holes, far from being just an isolated phenomenon, are an open door to understanding our universe and the laws that govern it. So, as we continue to explore, we can be sure that every answer we find will only lead us to more questions. Black holes are a reminder of the vastness of the universe and how little we truly know. In this journey of discovery, the mysteries of black holes invite us to keep exploring, to maintain our curiosity, and to never stop questioning what we think we know. Who knows what revelations are waiting to be discovered in the depths of the cosmos? The search for black holes is like trying to find hidden treasure in a vast ocean. As science advances, we discover new tools and methods that allow us to explore this mystery. But what does the future hold for this fascinating research? What awaits us on the horizon regarding these enigmatic cosmic objects? First of all, the detection of black holes has evolved impressively. In the past, we had to settle for observing the effects of their gravity on nearby stars or the gas surrounding them. Nowadays, gravitational waves have revolutionized our field of vision. Did you know that when two black holes collide, they generate waves in space-time that can be detected by instruments on Earth? This ability to listen to the universe is a monumental advance and promises to reveal much more about the nature of black holes. But what questions remain unanswered? The singularity, that point where gravity is infinite and the laws of physics as we know them cease to apply, remains a great enigma. How can we reconcile Einstein's general relativity with quantum mechanics? The search for a unified theory is one of the great challenges of modern physics, and black holes could be the key to solving this puzzle. Another intriguing aspect is the relationship between black holes and information. What happens to the information that falls into a black hole? This question has sparked passionate debates among physicists. The information paradox proposed by Stephen Hawking suggests that information is not lost, but its fate remains a mystery. Could there be a way to recover that information? Future research could shed light on this issue, altering our understanding of reality itself. As we look to the future, we must also consider the implications of astrophysics in cosmology. Supermassive black holes at the centers of galaxies not only influence the formation of these galaxies, but their existence helps us understand the evolution of the universe. How have these giants impacted the dark matter and dark energy that seem to make up most of the cosmos? The answer could radically change our view of the universe. The study of wormholes also appears to be a fascinating direction. These structures could act as shortcuts in space-time, allowing travel from one point to another instantaneously. But are they more than just a theory? With progress in theoretical physics, perhaps one day we will better understand these possible gateways to other universes or dimensions. Research on black holes is also driving technology. New telescopes and gravitational wave detectors are being designed to observe even more subtle phenomena. What amazing discoveries could arise from these advances? The possibility of seeing beyond what we think we understand is an exciting horizon. Moreover, international collaboration in black hole research is on the rise. Scientists from around the world are working together, sharing data and theories to unravel the secrets of the cosmos. How could this cooperation change the course of science? The union of brilliant minds could lead us to discoveries that today seem like mere science fiction. Of course, the exploration of black holes also has its challenges. The complexity of these phenomena and the technology needed to study them require significant resources. Are we willing to invest in this search? The answer lies in human curiosity, the desire to understand our place in the universe. As we move forward, we cannot forget the philosophical impact of our discoveries. The existence of black holes raises questions about the nature of time and space. How does this affect our perception of reality? Science and philosophy may intertwine more than we believe, leading to new reflections on existence itself. Black holes could also play a vital role in the search for life on other worlds. The formation of planetary systems around black holes could offer unique environments where life could arise. Could it be that black holes, far from being merely destructive, are also incubators of life? This is another field where future research could surprise us. Finally, black holes are a window into the future of physics. With each discovery, we get a little closer to answering fundamental questions about the universe. Are we ready to face the challenges that lie ahead? Human curiosity has taken science to unexpected places, and the future of black hole research promises to be just as astonishing. The possibilities are endless. And with each advance, we are one step closer to unveiling the secrets that the universe has in store for us. The exploration of black holes is not just a journey into the unknown, but also a quest for answers that could change our understanding of the cosmos. So, as we embark on this exciting era of discoveries, let us remember that the journey has only just begun. Close your eyes for a moment and imagine a vast universe filled with wonders and mysteries. Now think about those dark giants hiding in the immensity of space, black holes. Throughout this journey, we have explored their nature, their influence on the structure of the cosmos, and their connection to life itself. But what does all this mean for us? Why should we continue investigating these cosmic colossi? The answer is simple, because black holes are more than mere points in space. They are gateways to fundamental questions about our existence. What lies beyond their event horizon? What can the singularity teach us about the nature of time and gravity? It's not just about understanding how they work, but also about unraveling the secrets of the universe that surrounds us. The journey of knowledge is endless. Each discovery about black holes not only brings us closer to understanding their mysterious essence, but also forces us to rethink notions we believe to be firm. For example, what happens to the information that falls into a black hole? This question has challenged scientists and opened a deep debate about the relationship between gravity and quantum mechanics. The search for answers to these questions could revolutionize our understanding of physics. Looking to the future, research on black holes presents fertile ground for new theories and discoveries. Imagine a world where we can observe these phenomena directly and decipher the enigmas that have puzzled scientists for decades. Advanced technologies such as space telescopes and gravitational waves are at the forefront of this exploration, bringing us closer to the mysteries that still elude us. In this quest, we also find a link to our own existence. Reflecting on black holes is, in a sense, reflecting on the fate of the universe. Could black holes be the seeds of new universes? What does their presence tell us about the cycle of life and death in the cosmos? These are questions that invite us to peer into the abyss and question our place in the vast tapestry of space and time. Science, at its core, is a journey of discovery. Each answer opens the door to new questions. Thus, research on black holes leads us to explore not only physics but also philosophy and the very nature of reality. This dialogue between science and human curiosity is fundamental to our progress as a species. The influence of black holes is not limited to the theoretical realm. It has practical implications that could change our daily lives. From understanding gravity to developing new technologies, each finding in this field could have repercussions in various areas. From medicine to space exploration, science fiction could become real science, and that is an exciting prospect. As we continue our quest for knowledge, it is essential to keep an open mind. Black holes challenge us to think differently, to question what we thought we knew, and to explore the unknown. What other secrets does the universe hold? Each new theory, each experiment brings us closer to unveiling those mysteries. The passion for scientific exploration is what drives us forward. The history of humanity is filled with discoveries that have changed our perception of the world. Black holes are an integral part of that history, and their study teaches us that there is still much to discover. So what does the future hold for us? Only time will tell, but what is certain is that human curiosity will be the compass that guides us. It is crucial to remember that we are not alone on this path. The global scientific community works tirelessly to unravel the secrets of the universe. Each small discovery adds to the great puzzle of existence, and although black holes may seem unreachable, each advance brings us one step closer to the truth. Finally, the exploration of black holes is a reminder of our connection to the cosmos. It invites us to look up and ask about our place in this vast universe. Each of us has a role in this story, whether as scientists, thinkers, or the curious. The pursuit of knowledge is a shared journey that transcends time and space. So as you conclude this journey through the universe of black holes, remember that there is still much to discover. Curiosity is the engine of knowledge, and the universe is full of secrets waiting to be unveiled. Stay curious, keep asking questions, and never stop exploring. The journey has just begun, and the universe has much more to offer.